In this video, I'm going to explain cam profile with roller follower. Let us see the problem first. A cam is to give the following motion to a roller offset follower. Outstroke during 80 degrees of cam rotation, 12 for the next 45 degrees of cam rotation, return stroke during next 80 degrees of cam rotation, and followed by 12 for the remaining 155 degrees of cam rotation. The stroke of the follower is 50 mm and minimum radius of the cam is 50 mm. The follower moves with simple harmonic motion during both the outstroke and return strokes. Draw the profile of the cam when the axis of the follower offset by 10 mm to the center of the camshaft and the diameter of the roller is 15 mm. So in this problem, the sequence of operations of the follower is given. First outstroke, that is 80 degrees, followed by 12 45 degrees. Next return stroke 80 degrees, followed by 155 degrees. And stroke of the follower, that is maximum lift of the follower, is given 50 mm and minimum radius of the cam is given 50 mm. The follower moves with simple harmonic motion, both the outstroke and return stroke. The motion of the follower is given, that is the simple harmonic motion. So draw the profile of the cam when the axis of the follower offset by 10 mm. The axis of the follower is not passing through the center of the cam, it's offset by 10 mm, either right side or left side. It's not mentioned. You can assuming and accordingly you construct the cam profile. And diameter of the roller is also given 15 mm. So while constructing the cam profile, we should know that what is the minimum radius of the cam, that is the base circle and prime circle. The base circle is the minimum radius of the cam, that is given 50 mm, and prime circle is just greater than the radius of the roller for base circle. So with this information, we need to construct the cam profile. So before going to construct the cam profile, it's required to complete the displacement diagram. Here, this is the displacement diagram for the simple harmonic motion, both outstroke and return stroke. So outstroke 80 degrees, 12 45 degrees, return stroke 80 degrees, and followed by del 155 degrees. So here outstroke and return stroke I taken the 8 divisions, 8 equal divisions. And complete the stepwise procedure of the construction of this displacement diagram, you may watch my videos in my YouTube channel. I need not spend more time to explain in detail about this displacement diagram. It's already available in my YouTube channel. Now let us go for the direct construction of the cam profile. First, to take the convenient point and mark as a center of the cam, that is the O, at the center of the camshaft. Now draw the axes, that is x-axis and y-axis. Now take the center O is a center and minimum radius of the cam profile is given 50 mm, that you take 50 mm radius and draw the circle. This is the base circle of the cam. Now here the roller is offset by 10 mm. So now we take 10 mm as a radius and same center O as a center and draw the offset circle. Then draw the axis of the follower. The axis of the follower is tangent to the offset circle. Now see that this line is acting as a axis of the follower. Now the intersection of this line with the base circle, just mark the point, and at that point draw the roller. This point just mark as X, and on this line from this point X mark the center of the roller, that is the 15 mm diameter is given. 7.5 mm take radius and mark the point, and that point is assigned as A. Now the point A is the center of the roller and 7.5 mm radius, draw the circle. This is acting as a roller. Okay. Now the center of the roller, draw the circle passing through the center of the roller. Now the same center for the camshaft, and this OA is acting as a radius and draw the circle. Now join this OA. This OA is a reference line. The OA is a reference line. So from this reference line, we can measure the angle of outstroke, dwell, and return stroke. Now outstroke is 80 degrees. Just mark from this reference line OA to the 80 degrees, okay, that acting as a outstroke, and dividing this outstroke into the 8 equal parts, and assign the numbers and draw the lines which is passing through these points and tangent to the offset circle. See that? Okay. Now again you take this O8 as a reference and measure the other angles. Now on these lines, from the displacement diagram, we take the distances. From the displacement diagram, we take the distances. That is a 1B, 2C, 3D, like that. The same distances we can mark on these lines which are tangent to the offset circle and mark the points. Now complete the remaining strokes, that is the dwell period. Dwell period is 45 degrees. Dwell period means the follower remains the same height. There is no changes in the height of the follower. Okay. Next, followed by the return stroke. Again, you take the 80 degrees from this reference line and mark, and this is a return stroke. Okay. Now the return stroke also dividing into the equal parts, 8 equal parts, and assign the numbers and draw the lines which are passing through these points and tangent to the offset circle. Tangent to the offset circle. Now again from the displacement diagram, we can mark the points and assign points on these lines. Okay, now these points are there. Okay, now we can assign the what are the names are given in the displacement diagram. Same names you can maybe assign to all the points. Now you can see that A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S. This is the points. So now what we can do, now take these points as the centers and the roller, take the roller radius and draw the circles. You can see that we completed all the circles. Now we can draw the smooth curve, which is the curve is a tangent to all these rollers. Tangent to all these rollers. Start from the point X and end with point R, and R to X again it is coincide with the base circle. Now you can construct the smooth curve. This is acting as a required cam profile. This is acting as a required cam profile. I hope everyone understand how to construct the cam profile for offset roller follower.